In this video, we're going to go over how to run the Edge of Field Bioreactors tool. Denitrifying bioreactors are an edge of field practice where typically a buried bed of wood chips is placed along the edge of a field to intercept a portion of the tile drainage flow. Those wood chips act as a carbon source, so that carbon plus the oxygen limited environment is a good combination for this nitrate reducing bacteria to grow and therefore lead to denitrification. So let's go ahead and run the tool. We'll come over to our toolbox, go down to Precision Conservation Practice Siting, and our last option there is the Edge of Field Bioreactors. So we'll open that up and we can see we have 7 inputs, the first of which is our field boundary feature class. It's asking for the drainage table, an unfilled DEM, a D8 flow accumulation roster, the D8 flow direction roster, the GCirgo roster, and then our Z factor. Our output is going to be the bioreactor's polygon. So let's grab our field boundaries, drop them in. And we can see that the other inputs have been manually populated except for unfilled DEM. That is that new DEM. And then our Z factor, which will be 0.01. And the bioreactors was automatically named and going in the right direction, so we hit OK and let it run. While the tool is running, I'm going to explain how the tool works and finds these ideal locations for bioreactors. First, a mask is generated of all the tile drained fields, and that's based on that drainage table. Then the largest point of exiting flow accumulation, and it must be between 20 and 100 acres, is found along the border of those likely to be tile drained fields. This is our best guess of where a tile outlet may exist. However, like with all things, field verification will be needed, and local knowledge could be valuable in this sense. The next step is watersheds are delineated using that outlet as a pour point. And then a check is done to make sure that a minimum of 10 acres of upstream drainage falls within that current field. Next, the points along those fields are buffered out 100 meters. From those points, areas within 1 meter of elevation are checked for the 2 following conditions: that area makes up at least 0.5% of the drainage area to that point, and that the mean hydric percent is less than 90. If suitable, a square is drawn that is approximately 0.5% the size of the drainage area. So this gives you an idea of the actual size that your bioreactor would be. Alright, so the tool is just finished running, so let's take a look at what we got. It's been automatically added. I'm going to symbolize it to make them stand out more. I'll make them yellow. And we can see we've had quite a few placed within this watershed. So let's zoom in and take a look. Let's go where some are grouped together. And it's kind of hard to tell, but these squares are actually different sizes. The size is representative of what would likely to be built along that field. So now let's take a look at our attribute table and see some of the information we get from this output. Each location has a unique identifier from the point ID, and it has the field boundary ID that it would be associated with. We get the accumulation value that goes there. This is in acres. The minimum acreage, that's your size of the bioreactor, the elevation that it sits on, the percent hydric soil within that area. All of these will be less than that 90%. And then our basic attributes that come with every output. So alright, that's our bioreactor output. Here's a brief recap of everything we just covered in the video.